Last class we have studied about the Boolean algebra operators, Boolean function, and in this class now we will study about the Boolean function minimization. Because the digital computers use in the circuits the Boolean functions, we need to minimize the Boolean functions in order to make them cheaper, consume less power, and make it faster in running. And in this we use, in the simplification of Boolean functions, we use the Boolean identities, that is the Boolean laws, using the product form or the sum form. The product form is nothing but using the AND, sum form uses the OR. Here we have various Boolean identities. We will go through one by one. Here is the identity law. Identity name is given in the first column. Using AND form is given in the second column. Using OR form is given in the third column. The first law is identity law. There is no sequence in these laws. There are actually 10 to 12 laws. We can go in any order. Here it is given identity law. Identity law says that 1 and x is nothing but x. 1 dot x is x. That is, in place of x you can place 0 or 1. 1 dot 0, that is, in the AND gate truth table we have studied 1 dot 0 is 0. That is nothing but x. 1 dot 1 is 1. So whatever we place in the place of x, that will be the result here. So 1 and x is x in the identity law AND form. Coming to the next OR form of this identity law, 0 plus x, 0 or x or 0 plus x is x. Whatever we place in x, that is 0 or 1, it will result in x. 0 or 0 is 0, 0 or 1 is 1. Coming to the next law, that is the null law, 0 and x, anything with a 0 and is 0. 1 or x is 1. That is 1 or 0 is 1, 1 or 1 is 1. So 1 or with x is 1. Next, coming to idempotent law, x and x is x. In the OR form, x or x is x. Inverse law, x and x complement is 0. In the OR form, x or x complement is 1. X is nothing but placing 0 or 1. So whatever value you place in x, that is in the AND form, x and x complement. If x is 0, x complement will be 1. 0 and 1 is 0. In the OR form, 0 or 1 is 1. If x is 0, x complement will be 1. If x is 1, x complement will be 0. And coming to the next group of identities, that is, these are the three laws which are based on the algebra that we have studied earlier. Commutative law says that x and y is same as y and x, and x or y is same as y or x. Associative law, x and y and x is equal to x and y and x. OR form, x or y or z equal to x or y or z. Distributive law says x or y z, that is x plus y z. We can say here plus or x or y and z is equal to x or y and x or z. Similarly, the exchanging of plus and dot gives us the OR form in this distributive law. That is, x and y or z equal to x and y or x and z. Coming to the next set of laws, absorption law. In the AND form, x and x or y is x. X plus y, that is x or y, gets absorbed here. OR form, x or xy is x. You can place zeros or ones in place of x, y, and you can see the result. It gives x. De Morgan law. In the AND form, x and y whole complement equal to x complement or y complement. Each individual variable is complemented with the negation of the form. In the OR form, x or y whole complement is equal to x complement and y complement. Whatever plus is there in between is converted to dot. If dot is there, that will be converted to plus. And the inverse is applied on the individual variables. This De Morgan's law can be applied not only on two variables, it can be applied on any number of variables. Coming to the next double complement law, x complement whole complement is nothing but x. And let us see example of minimization of the function f of x comma y comma z equal to x or y and x or y complement and x z complement whole complement. Minimize this Boolean function using the identities that we have studied earlier. You can see the solution here. The same function we have written in the first statement. In the next statement we have minimized. What we can do is here we can apply the De Morgan's law on the x z complement whole complement. That is, apply the De Morgan's law. It gives us individual variable complement and changing the AND form to OR, that is x complement or z. And you applying the distributive law on the first two terms, it gives x and x, that is applying like product on the first two terms gives the third step. And applying commutative and distributive laws on this will result in x or y complement plus x or taking common as x and y plus y complement. In the last term, x complement plus z remains same. Applying the inverse law on this, that is y plus y complement is nothing but 0. So we have applied inverse law on this and that gives us x or 0. And here y plus y complement in the inverse law gives 1. So that is x and 1. And applying the idempotent law on this gives x and x complement plus z. And again applying the distributive law on this, expand this, x complement plus x z. Applying the inverse law on this gives the first term makes it as 0 plus xz. Anything or with 0 is nothing but x. We have studied in the idempotent law. So the result is xz. We cannot still further minimize it. This is the minimized expression for the function f of x comma y comma z. So this is how we minimize using the Boolean identities. Thank you.